So today we are starting a brand new unit. It is going to be radicals and right triangles. So in order to solve these right triangles, we will need extensive knowledge of radicals. How do you simplify them? How do you add them? How do you subtract them, multiply, divide them? So that's our goal today, is to get through all of that. So we have a lot to do. Let's get started. So radicals, here we go. There are two parts of a square root sign. The outside is called the radical, and then whatever is inside, whatever that may be, whether it's a number or a group of numbers or a decimal, whatever it may be, is called a radicand. So I'll be using that word radicand a lot. I'm speaking of what is underneath, what is inside the radical. All right, so we've seen these before. I don't need to reteach you what square root is or what radical is, but I often with my K-level students get a lot of questions about these two problems. Now, if I just walked up to you and said, hey, what's the square root of 16? You would say 4. Okay, but if I said the one on the left, if I said solve that problem for x, what you would do is you would try to solve for x. You would need to undo this squared. How do you undo the squared? Square root. Okay. Now, when you square root both sides, something happens. When you square root both sides of an equation, when you have a problem with a degree of 2, yeah, you're going to have 2 answers. So I have students on quizzes for this problem, they'll write plus or minus 4. But no, that just says, what is the positive square root of 16? There's no negative in front of it. So the square root of 16 is still just 4. It is not plus or minus 4. But when I'm solving an equation, see how this has an equal sign? When I'm solving an equation, and my equation had a degree of 2, there better be 2 answers. And that's where the plus or minus comes from. So now you know when it's appropriate to put plus or minus and when it is not. Okay, so it's good to memorize the perfect squares from 1 to 12. Those are numbers that come up all the time, and the more of them you know, the faster and more smart you're going to be able to solve these problems. Okay, everyone just yell out the answer. 8 squared. 64. 64. Memorize these if you haven't. 2 squared.
4.
12 squared.
144.
That's a good one. 7 squared.
39.
49. 5 squared.
25.
10 squared.
100.
3 squared.
9.
6 squared.
36.
9 squared.
81.
11 squared.
121.
That one is a tough one. Okay, 4 squared.
16.
Okay. So we know that squaring and square rooting are inverse operations. So if I say that 7 squared, if I say that 7 squared is 49, the opposite of that is saying, what is the square root of 49? What's the square root of 49?
7.
Okay, now let me tell you what I see a lot. I see this on quizzes all the time. Square root of 49, and I have kids put 7 squared. Just be careful and make sure you understand what these mean. The square root of 49 means what 2 numbers, because it's a square root, there's a little 2 there, but it's understood, we don't write it. What 2 numbers could I multiply together to get 49? What number could I square to get 49? I can't square 7 squared, but I can square 7. So square root of 25 is just plain old 5. Square root of 121, plain old 11. Don't make that mistake of putting a squared on it. Okay, like I was saying earlier, squaring and square rooting are like adding and subtracting. They undo each other. So there's no reason to go to your calculator and square 15 and then take the square root of it. There's no reason, because the square root and the squared cancel. The answer is plain 15, no embellishments, no squared, no square root. They're gone. Totally, totally gone. So when you have situations like that, you may simply cancel them out. You don't need to actually square the radicand in those cases. Same with this. Square root of 10 is squared. I'm putting them in a different order, but they will also simply cancel. You don't get 100. You just get 10. You don't get 3,294 squared. You just get the radicand. Now, here is the difference. I want everyone to pay attention to this last example, because this is where things really change, and this is where students make mistakes. On this last example, yes, the squared and the root 5 cancel, but you can't forget about the 2 outside. That 2 is separate, and that 2 gets squared as well, because the 2 is in parentheses. Yes. So this is probably the most commonly missed problem of this entire unit. And you're probably surprised. You're like, Ms. Tan, that problem's really easy. But some of you will miss it, so I want you to write that one down in your notes if you want. You have to square the 2 and the root 5. Anything in parentheses needs to get squared. So the answer to this problem is not 2 root 5. No, it's not just what was in parentheses. It's actually 4 times 5, right? Because those cancel. So 2 squared is 4, and the square root of 5 squared is 5. So what's the answer to this problem?
12.
Yeah. Who knew 2 root 5 all squared ended up being a whole number, integer 20. All right.
I knew.
Yay! Now, the radicand is not always going to be a perfect square, and you're not always going to be able to cancel out the inverse operations. So when the radicand is not a perfect square, you have 2 options. You can either simplify the radical, or you can use your calculator and get a decimal. Which one of those is exact?
Simplify.
Oh, yeah. And putting it in your calculator to get a decimal is approximate. 95% of the time, 95% of the time, Miss Tanton is going to want exact. I love exact. I mean, this is not an exact number, 95%. It's just an estimate. Every now and then, if it's a real-world problem, or if we have a reason to write it as a decimal, we will. But the rest of the time, no. You're not going to write it as a decimal. So, like, here's my analogy to fractions. If I gave you that fraction, would I want you to put this in the blank? No, that's approximate. That's you rounding. Instead, I would rather you simplify it. That would be the correct answer. 0.33 would not be the correct answer. So same with radicals. Okay, now I have a really fancy story that I used to tell to go with it, but we just don't have time, so I can't tell my fun. But instead, it's really not that great of a story. It's about the jail. Okay, but instead, we're just going to dive right in. How do you simplify a radical? If you put square root of 245 in your calculator, you're going to get a decimal. It is not a whole number. So I don't want the decimal that the calculator gives you. Instead, I want a simplified form. And to do that, we are going to do a, does anyone know?
Factor tree.
Factor tree! Okay, so to do this, we need any 2 numbers in the universe that multiply to get 245. With what 245 ends with, what number is for sure going into 245?
5.
Yeah, let's just start there, even though it might not be the best option. 245 divided by 5. You're welcome to put it in your calculator. There's no shame. Okay, so 49 times 5. When you see a prime number, do y'all know what the prime numbers are? Some of my students all knew a song, a prime number song. The prime number is a number.
I remember she made us memorize it.
Okay. There you go. So a prime number is a number divisible only by itself and 1. So okay, well, guys, I am recording this. So when you see a prime number, you stop in your tracks and you circle it. 49 is not prime, but 5 is prime. When a number is prime, that's the end of that branch of the tree. So you stop there. This one can go further. That's a perfect square, of course. It's 7 times 7. Those numbers are prime. So then, because this is a square root, what are we looking for?
Perfect squares.
Okay, you might have learned that way. We're good. We're looking for pairs. Good, Fong. We want pairs of numbers. Only pairs can escape the square root sign because we're finding it's a square root. Now, if it was a cube root, we'd be looking for triplets. But no, we're looking for twins. We're looking for pairs. When you find a twin, when you find a pair, you write it on the outside of the square root. It has escaped the jail. The 7s are no longer underneath the square root. They're not part of the radicand. And then, 5 didn't have any pair, no twins. So 5 is left in the radical. It is the radicand. So 7 root 5 is the answer. And if we wanted a decimal version, we could put that in our calculator. Let's try another one. 450. What do you want to use? Two numbers that multiply to get 450.
45 and 10.
Let's do it. 45 and 10. Now, neither of those are prime, so don't circle either of them. Let's go with the 10. What you got?
2 and 5.
2 and 5. Prime and prime. Circle, circle. 45.
9 and 5.
That's one of the options. 9 and 5. 5 is prime, circle. Look how pretty this tree is. That's a fun little tree. Do you see any pairs? What do you see? I see 5s. Now, I recommend that you cross them out so you know that they've been used. I found a pair of 5s. I cross it out. Do I write 2 5s down? No. The pair together escapes. That means a 5 escaped. A 3 escaped. And a 2 lonely 2 never found a pair. Now, when more than one number escapes, or more than one number is stuck in the radical, you multiply them back together. Because think, when we separated this, was that 45 plus 10, or was that 45 times 10? Times. And I have students ask me all the time, do I add them back together or do I multiply them? Well, if you pull them apart with multiplication, you better put them back together with multiplication, okay? So the final simplified answer is 15 root 2. Factor treeing, okay? Okay, let's try one more. Last one, and we need to move on to adding. Now, let's go ahead and start factor treeing. Let's do 12 and 10, 5 and 2, prime, prime. We can do 6 and 2. Woo-wee. Okay, here's what we don't want to do. We don't want to forget about that 7 that was already escaped. The 7 that was already there, it was part of the problem. Don't forget about it. So I'm going to write that first. That's my priority, is to write that 7. Okay? What's a number that escaped jail? Escaped the radical. A pair of 2s. Notice how I'm crossing them out so that I know I used them. Oh my goodness, there's 3 numbers that just couldn't find a pair. They tried so hard, but no one was there to match with them, so they weren't allowed to escape the square root sign. So we've got a 2 left, we've got a 3 left, and we've got a 5 left. We don't add them back together, we multiply them back together. So, final answer, go ahead.
30.
14 root 30. Final answer. How can you check to make sure you did this correctly in your calculator? How can you check? So put the original problem in. Yeah, put 7 root 120 in. 7 root 120 is 76.68. Then put your answer in. 14 root 30. 14 root 30 is 76.68. If these match, you just graded your own quiz. You know with certainty whether it's right or wrong. You don't have to wonder if you did it right. Okay, we're going to move on to adding and subtracting. The great news is, when you forget how to add and subtract radicals, just think back to variables. Just think back to adding and subtracting x's and y's. What is 2x plus 3x?
5x.
It's not a trick question. It's 5x. What's 4x plus 3y?
4x plus 3y.
Exactly. The difference is these were
X's.
like terms, same variable, and these were not like terms, so we could not add them together. Even though radicals are not variables, we can treat them like variables. We can treat them like variables. So, the radicals must be the same before we can add or subtract them. So looking at these, exact same thing I just showed you. These are like terms, So we're allowed to add them together. These are not like terms. So our answer is just the rewriting of the problem. Do you see that? So it's like I have 2 root 3's in this hand, and I have 5 root 3's in this hand. How many root 3's do I have? I have 7 of them. Whereas in the other problem, I've got 4 root 5's and 3 root 7's. What do I have? Well, I still just have 4 root 5's and 3 root 7's because they're different radicals. They're different terms. Okay? So try these 2 problems. Now, on first glance, you're like, well, root 3, root 75, those aren't the same. But what do you think about on second glance? You have to simplify it. Yes, you do. What do y'all want to use?
5 and 15.
Okay. So now, this is 5 root 3 plus, okay, there was already a 2, and then a 5 escaped. Oh, yay, now they're like terms. This is really 5 root 3 plus 10 root 3. You see that? So we simplified and realized, oh, these really are like terms. Now I can combine them into one term. What's the answer? Nobody? What's going on? Huh? I said, what's the answer? Yeah, 15 root 3. 5 root 3's, 10 root 3's. How many do I have? I have 15 of them. 15 root 3. Let's try this next one. I'm going to go to all the radicands that can be simplified. Ooh, I'm going to start simplifying them.
No.
Oh, okay.
On Zoom. I think you stopped sharing. We can still see her screen though.
Okay, so what I'm doing is I'm working on each one of these that was not fully simplified. 8 was not simplified. 18 was not simplified, so I am factor treeing like crazy. So this is minus. I brought that minus down. There was already a 3 there. A 3 escapes. And a 2 was left over. I'm going to bring that plus down. And there's nothing to do with that root 3, so I'm going to bring that root 3 down. I'm going to clean this up a little bit. 5 times 2 is really 10 root 2 minus 3 times 3 is really 9 root 2 plus root 3. 2 of these are like terms. The other one is not. So I'm allowed to combine these into one term. What do you get?
90 root 2.
So you get 1 root 2 plus root 3 because we had 10 root 2 minus 9 root 2. So 10 minus 9 is 1. You don't need to write the 1 because 1 is understood. 1's already there. All right, let's move on to multiplying and dividing. Okay, so multiplying and dividing, when in doubt, think back, what would I do if these were x's? So what's 2x times 3x?
6.
6
Squared.
x
Squared.
Okay, so notice we multiplied 2 times 3, but we didn't ignore this like adding and subtracting. We also multiplied x times x. Same rule applies with our radicals. 4x squared times 3x. So you look at the numbers separately, 4 times 3, then you deal with the variables.
That's cute.
Yes. Okay, same thing goes with radicals. I'm going to multiply the numbers on the outside. 3 times 4, separate from the radicands. Totally separate, never mingle. A number on the outside, a number on the inside, they're totally different numbers, so they should never mingle. So 12 root 10, that's all there is to it. Keep the outside together, keep the inside together. All right, let's try some. These are super easy. I kept them easy. What's root 3 times 2 root 5? What do you get?
2.
2
15.
root.
15.
That's all there is to it. Okay, try this one.
24 root 10.
That's all there is to it. Very good. Numbers on the outside, separate from any numbers that happen to be inside the radical. Okay, dividing works the same way. I can divide the numbers on the outside separate from the numbers on the inside. So I can complete 6 divided by 3. And I am even allowed, it's counterintuitive, but I am allowed to do root 8 divided by root 2 because they are both radicands. I'm allowed. What do you get?
2.
8 divided by 2. Well, let's write the middle step. 8 divided by 2 is 4. So now we're not done. 4, what is the square root of 4?
2.
2. Whoa! So 6 root 8 divided by 3 root 2 ends up being plain old 4. 4 is a perfect square, and that's why the radical went away. That's why from here to here we got 2, because the square root of 4 is perfect. We didn't need to factor tree it because it's one of our perfect squares that we have memorized. Okay, let's try examples. Ooh, I know I'm allowed to divide these. So this equals 4 root, what?
5.
5. That's all there is to it. Done. You don't need to factor tree the 20 because you're allowed to divide these. Okay, this one needs some work. What do we want to do?
Factor tree.
Yeah. Okay, what do you want to use?
9 and 5.
Awesome. Prime. Okay, so new numerator is what? What's our new numerator? The 3 escapes. 3 root 5 over 9. You're allowed to simplify the numbers on the outside. What does that reduce to?
1/3.
1/3. I'm not going to write the 1 because it's understood. How do we feel?
Okay.
Okay, treat the numbers on the outside, simplify them separate from the inside. Okay.
I don't get it.
Which part? Where did I lose you? All I did was, with the 3 root 5 divided by 9, is I canceled out the 3/9 and I changed it to 1/3. 3/9 equals 1/3. But I chose not to write the 1 because mathematically you're not required to.
Okay.
Okay. Checklist for simplifying radicals.